my nails and I cannot get the pencil out of the thing. Like I can't reach it anymore. All right, so we did the parametric stuff on Friday, I guess it was. I feel like the weekend was really short. Already ready for another weekend. But we haven't done inverses yet other than that one inverse problem. So let's do another one. 16, f of x is equal to x plus 3 over x minus 2. So remember with f of x, that's just y. And so our phrase or whatever for inverse is swap x and y and solve for y. So I'm going to have x is equal to y plus 3 over y minus 2. So then the next thing I'm going to need to do is multiply by y minus 2. So I'm going to have x times y, and I'm just going to do this as one step to save having to write, minus 2x equals y plus 3. And so now when I'm trying to solve for a variable, I need to get all of the terms that have that variable on one side and all the other terms on the other side. So I'm going to move the y over and this 2x over. So I'm going to have xy minus y equals 2x plus 3. So then I still have two different y's, but because one of them has an x with it, I can't just combine them. So I'm going to take a y out of that. So I'm going to have y times x minus 1 is equal to 2x plus 3. And then finally, getting y by itself, I divide by the x minus 1. So y is equal to 2x plus 3 over x minus 1. And in my personal opinion, that's about as hard as they get. If you can solve the ones with the letters in a fraction, that should be pretty much all you really have to worry about when it comes to like difficulty of these ones. If you have something like 20, f of x is equal to the square root of x cubed plus 5. Still swap x and y. So x is equal to the square root of y cubed plus 5. So now y'all walk me through what I need to do. Square both sides, so x squared is equal to y cubed plus 5. Now what? Trying to get y by itself. So x squared minus 5 equals y cubed. And lastly, what would I do? Yep, cube root, so y is equal to the cube root of x squared minus 5. And no matter what root or power, whatever it is, you would do the same thing. So for some reason, people get more confused about these sometimes than the one we just did, but the one we just did is much harder than this. I mean, I've done them so long, neither of them are particularly difficult for me personally, but from what I've seen from teaching is that people tend to struggle more with, well, I think overall they think 18's harder, but they tend to miss 20 more often than they miss 18 for some reason, or whatever number that was, 16. All right, are we okay with actually finding inverses? So I think last year we may have briefly done this last year, but after we find the inverse, we can actually verify that they are inverses by plugging them into each other using the stuff that we did in 1.4. We can basically take the composite of the two functions, and if it gives us out an x by itself, so not like 2x, not negative x, if it just gives us out an x, we know that they're inverses. And so you could check the ones that we've done by plugging them back in. But I'm not going to require that. But if you get to a quiz or a test and you're like, especially with these fraction ones, if you're like, I really don't know if I did it right, the beauty is when you go to plug them back into each other, the things are going to cancel. And so there's not really a whole lot of work involved usually to actually solving those and checking them. But the book actually has an entire section about verifying that the two functions they give you are inverses. I don't know with certainty that they all should be, but I think they are. It's actually funny, this one, x plus 3 over x minus 2, and then 2x plus 3 over x minus 1, they actually, problem 32 is actually verifying that these are inverses of each other. So it's kind of funny that just so happened. I don't think they did it on purpose. They may have, but anyways. 32 would be the verification of this problem. So, which I might do for you in just a minute just so you see it. But let's start with 28. We've got f of x is equal to x plus 3 over 4, and g of x is equal to 4x minus 3. And so to officially verify, we are supposed to do f of g of x and g of f of x. When you are just checking for your own personal purposes or whatever, I would really only check one of them. It's not to say that every time if one of them is, that means that they're both going to be, but they should pretty much work out. Unless you've really done something wrong, it should work out. So f of g of x is going to be first. So that means that the equation g of x, so this 4x minus 3, is getting plugged in for x and f of x. So basically, I've got 4x minus 3 plus 3 over 4. So my 3's canceled, because I had negative 3 and positive 3. So I'm left with 4x over 4. The 4's then cancel, and that just leaves me with x. So you're going to notice some of the verifications work out pretty nicely. 32 to verify 16, it's not so pretty. Then let's see, g of f of x is the other one. So now this x plus 3 over 4 is getting plugged in for x and g of x. And so we have 4 times x plus 3 over 4 minus 3. So 4's cancel, which leaves you with x plus 3 minus 3. And then 3's cancel, which leaves you with x. And so that one also worked out. Then 30, got f of x is equal to 7 over x, and g of x is equal to 7 over x. Now, at initial glance, do these look like they're inverses of each other? No, because they're the same, okay? So, let's find out if they actually are. So, f of g of x. So, I'm putting 7 over x in for x and 7 over x. So, 7 over 7 over x. So, when we divide by a fraction, we multiply by the reciprocal, keep, change, flip. So, 7 times x over 7. 7's cancel, and leaves me with an x. Now, I'm going to be really honest, because this one is literally the same thing both ways. I probably would not go ahead and do the g of f of x if I was just doing it, but I'm just going to do this because it's going to be the same thing, and I'm just going to put that it's equal to x because it's the exact same math we had just done. And it's not going to change. If it was that way for one, it's not going to change for the other one. So, and if I were to give you this problem on a quiz and you just did that, I'm going to realize you did it because it's the exact same thing, and it's, I'm all about as little writing as possible, as y'all know. So, all right, let's do 32. Just because the checking isn't quite so pretty, I will do one of them for you, and then I'm going to have you try the other one on your own just because it is fractions and a fraction, and, you know, it is what it is. So 32, f of x is x plus 3 over x minus 2. And g of x is 2x plus 3 over x minus 1. So do y'all want me to do g of f of x, or do you want me to do f of g of x? So basically, which one do you want me to plug it into? Because you have to do the other one by yourself.
Just plug it into the g.
All right, so you want me to do g of f of x?
Yes.
Is everybody okay with that?
I really don't care.
I know, I feel like those might be hard. So.
Basically, they're this. I mean, more or less, they're going to be the same, other than this one has a 2 in front of it. So. All right, so that means that this entire function here is getting plugged in for x in the top and in the bottom. So 2 times x plus 3 over x minus 2 plus 3 over x plus 3 over x minus 2 minus 1. Now, just to avoid having to rewrite this entire thing over again, I'm going to go ahead and multiply this 2 by the numerator and just replace it. Y'all tracking what I'm about to do? I'm going to make this 2x plus 6 and get rid of the 2 in front. Just to save having to rewrite the entire thing again, because that takes up a lot of space. And somehow, when I did it on paper, I managed to fit both of them down in this little tiny space because I wrote very small. All right, so when I have a fraction and it's being added to something that's not a fraction, what do I need to do?
Make it a fraction.
How?
By multiplying. Get a common denominator.
Yes, so my common denominator is going to be x minus 2. Now remember, it's x minus 2 over x minus 2. And they happen to top and bottom obviously be the same every time we do these. Well, the inverse problems, obviously, it is the same. But when we do these problems in general, if we weren't finding the inverse, it's not always the same denominator. Also, I don't think it was your class, but I did have a class recently that we were doing something like this. And they just multiplied by like 1 over x minus 2 instead of x minus 2 over x minus 2. So just make sure that it's got to be multiplied by 1 or you're completely changing the problem. So just make sure you pay attention to that. So now, this is going to give me, since I'm going to have a common denominator, I'm going to write this as one combined fraction on the top and one combined fraction on the bottom. So I'm going to do my giant fraction here. So I've got x minus 2, and then on top I've got, this is 3x minus 6, so 2x plus 3x is 5x, plus 6 minus 6, so that's going away, so I'm just going to leave that as 5x over x minus 2 to eliminate extra steps, okay? So this was, here, I'll just do this. This was 3x minus 6 so that we can see what happened there. So now on the bottom, I'm going to do the same thing. So I've got, it's going to be over x minus 2, obviously. So all this minus 1 here does is basically, you can either just multiply the 1 through or you can make it, do the minus. But this is going to become minus x plus 2. So now I'm going to ignore this in the middle, and I'm going to basically look at what's written in red on top and what's written in green on top. So x minus x, so that goes away. And then 3 plus 2 is 5. So I have 5x over x minus 2 all over 5 over x minus 2. Now, keep, change, flip. 5x over x minus 2 times x minus 2 over 5. And now all this lovely stuff cancels. X minus 2's cancel, 5's cancel, and I'm just left with x. And so despite the fact that it's not a very pretty setup, the answer ends up being really nice. It doesn't end up being something super crazy like when we just solve these type of problems in general. So what I want you to do is on your own right now, do f of g of x. And I'll work it as well while y'all do that. And I'll freeze my screen so you can't see it. And then we'll go over it. And then we'll, unless y'all have questions, we'll be done for this section. Things appear to be working out nicely.
It's not as scary as it looked at first.
Like before I did the first one?
Yeah, the first one looked kind of scary, but then seemed to get a bit more friendly.
You setting up the first one, I thought I had no chance.
It's like people. Intimidating when you first see them, but then once you get to know them, they're actually pretty
I was
nice.
thinking like setting up someone. I was like, what are you
I was like a
talking
blind date?
Yeah, that's all. Like what?
I don't think I did something wrong, but my answer was not pretty.
You didn't get X?
No.
Yeah, you definitely did something wrong than I did.
Virginia, did you get X?
Yes.
Josh, did you get X?
Yes.
Okay.
It's like you drew that.
Did you plug in the right thing?
Yes.
Are you
Okay.
sure?
Did you
Wait.
multiply by x minus 1 over x minus 1?
Wait. Seeing all the right steps.
Did you get to this part?
No.
Top or bottom?
Bottom. I got the bottom wrong.
The bottom
I
is
got
wrong?
the top right.
So 2x plus 3, so then obviously the denominator is just x minus 1. So then we had negative 2 times x and negative 2 times negative 1. So then what I wrote in green, which you can't see because my finger's up there, is that it should be negative 2x plus 2 because the negative 2 times the negative 1. Did you get that?
Yes. Oh, okay. I see what I did wrong.
Okay.
Wait, did I? Oh, wait.
So the top, but you have the top right, right? Like this part is
Yeah.
right? Okay. So then the problems to add for what I gave you on Friday, I think we stopped at like 11 or something. Anyways, 15, 21, 27, and 31. There are more odd ones within these sections of the stuff that we just did today that if you need to practice, you can. But I took them off because I feel like you probably don't need to do that many. But 31 is going to be similar to this one, but there's no variable in the numerator, I don't think. There is on one of them, but the other one does not. So they should still end up pretty, but